Cartesian product is very important in the set theory, and it is also important in the relational algebra. In this video, I'm going to talk about the Cartesian product. And we are very familiar with this kind of product. We have already done it in the set theory, and I'm going to give an example from the set theory about this Cartesian product. Let's say a set contains the elements AB and another set contains the element CD. If we do the Cartesian product, what will happen? It will pair up the elements of two sets, like in first pair AC, then in second pair I can write AD, then in the third pair BC, and in the fourth pair BD will be appeared. What does it mean? It means that from first set with the second sets all the elements. So let's go back to the relational algebra and relational model. If we want to do the Cartesian product on the relations, we need two tables. That means it is actually binary. Unlike the projection selection operation, we do it in only one table. But in the Cartesian product, we have to consider two tables at the same time. Let's have a look of this example. At first student table and next class table. Here two columns and here one column. If we do the Cartesian product, and here is the relational algebra of Cartesian product, and this is the output. Like set theory, here we combined or paired up the rows from one table with the rows of another table. Like with first row John Smith, we have paired up with the first row of class. That means John Smith math is the one row of the Cartesian product. Next, John Smith IT is another row of these Cartesian products, and so on. Okay, another example. Here S1 one table and R1 another table. If we do the Cartesian product, then this table will be appeared. So this is the basic concept of Cartesian product of relational algebra. Next, I am going to talk about the union operator. This is another important operator in set theory. Let's go back to the set theory. Say here is a set AB and another set BC. We want to do the union, and here is the result. Now I can say union operator combine all the elements from two sets. In the same way, student is one table, teacher is another table, and here is the union of two tables. But remember, if we want to do the union of two tables, we have to consider two things. And these things are called union compatible. So now we have to know what is union compatible. So I am going back to the idea of union compatible. Let's have a look of union compatibility for two table schema. Student 1 table and attribute SID, name, GPA. Another table is semester. Also, here is the ID and year. My question is, can we do the union of these two tables? Answer is no, because this table has 3 attributes and this table has 2 attributes. So we cannot do it. If there are 3 attributes like name and year, can I do the union? Answer is still no. Why? There are 3 attributes and there are 3 attributes, then why we cannot do it? Because here SID integer, okay, name, worker, it's okay, but here's GPA is the floating and here is the date type. So if we want to do union, then we have to make it union compatible, and in union compatible all the corresponding rows should be in order and also the character type or data type also should be same. But here CGPA is the float type and here is the date type, so these are not the similar, so we cannot do the union of these two tables. So this is very important concept, not only for the union but also for the intersection and set difference. So I'm now going for another example. Here is this one table and here's the S2 table. Both are the seller table. Okay, and here SID name rating is, that means we can do union of these two tables. So if we do the union, then we will get all the contents of these two tables. So 22, 31, 58, and here some exceptional values. Here are some exceptional values like 44, it also appears, and 28, it also appears here. So this is how union actually works, and now I'm going to the next topic of set difference. It is also very important. It is also an important topic, and I'm going back to the set theory to understand it from the set theory concept. At first, I am writing the to set. So if I say what will be the output of these sets after doing the set difference, then I would say the output is A, because in the set difference we have to eliminate the common value of two table and eliminate the second row values of value of the second rows. And also eliminate the value of the second set. What if I write it in this way? Like I write in BC and AB. Then what will be the output of the set difference of these two sets? Then it will be appear as C, because here is the common attribute and here is the second set attribute, so left only C from the first table or first set, so only C left from the first set. So this is the output. Same thing is also true for the set difference in the relational algebra on relations. So here is the student table, here is the teacher table, and here is the output of the set difference of two tables. So from the first table and the second table, we got the common elements like John Smith, Joey Johnson. Ashley is not common here, and Rebecca is not common here from here. So Joey will be eliminated from the first table, and Rebecca Ashley will be eliminated from the second table. So left only Sarah, David, Amanda, and Joel. Sarah, David, Amanda, and Joel. So if I write it in different order, as like I write it in S2 minus S1, then from these two tables I have to eliminate the common at first, as like Lubar and Rusty is the common. Lubar and Rusty are the commons of these two tables, so I am going to eliminate it, and next left only Dustin from the first table. So this is the output of S1 minus S2, and this is the output of S2 minus S1. I think you get the point and it is understandable now.